Hey everyone, how are we doing? It is Tuesday. We're here to do some work. So we've actually done all of chapter 5, so we can do whatever we want right here. It's our time. Is anyone in the chat right now? Feel free to say hi. We could do the data analytics assignments. We can do whatever. I might go grab the data analytics playlist and put it in the assignment playlist. Let's go look at that data analytics playlist. Playlist right here. Upcoming playlist. What? Oh, pivot charts. Pivot charts, pivot tables. Okay, there's a really cool playlist right here if you haven't seen it. The pivot charts, pivot tables playlist. And still hasn't changed much in the last day. Oh, you can't even see the screen. Let's go look at the screen. Go to the main screen. Okay, I'm gonna make sure this is there for our class. So we got the modules. Go grab this. And we're gonna go put it in the assignments. If you're in the chat, feel free to say hi. Let's go here. We got the data analytics. We're halfway done with pivot with data analytics after this. My gosh, the semester's flying by. So video help. Video help. I can mainly say in the, there we go, make that much bigger right there. So there you go. Bigger's better. There we go. Video help. Okay. Do not copy, people. Do not copy. Put a big do not copy on this. Put a big do not copy. Yeah. All assignments are always checked via similarity. Do not copy. Write your own things. It's not that bad, I promise. All right. But we'll do some chapter 6 or something. What do people say? Maybe I'll send an announcement and say, hop in. Office hours are open, and just me in the background talking right there. Just say, hey, yo, what do you want to do? Mewbot's not even awake. Mewbot's awake. He's here. He's being a good Mewbot. We don't got any chill music going anymore. We do. Music's playing, right? Don't listen to the stream. Yeah, there we go. We can hear it. Okay, let me send out an announcement. SI reviews. Okay, add announcement. Office hours. Taking questions. Join live. Join here. Okay, there it is. Link works. Cool. Okay, send it out. Let's go to Discord too. Discord. Got a lot of messages on Discord. I got tagged in a message. Oh, people are helping out. You may want to bookmark it. I think I did a nice job. We're going to question things similar to example of the campus content. I can do practice questions during office hours. Maybe I'll do some of those right now. It's a very common question, like, what does the exam look like? Just me looking. Great random screen capture. Thank you, Discord. There we go. There we go. Great random screen capture. Great random. Immortalized on Discord right there, being like, there we go. Okay, if you're in the chat, feel free to say hi, but we're going to do some, wonder if I redo it. Let's see right here. Let's see what happens. It's just that. There we go. Can I disable preview? Oh, look at that. Oh, look at that. Perfect. Okay. Let's do a few random questions here. Let's do it. Let's hop to the main screen. And this section of the video will be chapter 5 on the exam. So let's talk about chapter 5 on the exam. I'll probably reference this to people. Exam 1, chapter 5 example questions. This goes to all 201 and 207 classes. So there's a few ways chapter 5 can be broken up into knowledge. The chapter 5 breaking apart would probably be 1, conceptual ideas about the normal curve. This is not everything. Oh, I'm going to do z-scores and finding them. And also we have the empirical rule questions. And then we have applet questions. Applet questions? Okay. So here's how I would break it apart into what you should know and how you should be able to do it. And so when you look at this right here, a lot of people understand conceptual ideas. Well, like, what could you ask? You could do things like, how do we check normality? Normality can be checked with things like a normal probability plot, a histogram by looking at it, in addition to goodness of fit test. Check out the notes on those. I'm just kind of mentioning things. You can do things like, I'm trying to think of another good conceptual one here. Percentiles, you can talk about percentiles. Where is the 99th percentile? It would be on the right side of the curve. Things like that. Where's the 99th percentile? Where's the median? Conceptually, ideas on the curve where we should know that they're at. What does percentile mean? It means the area below a certain point. So if you say you're in the this percentile, it means this percent of data is below you. So when you say percentile, if you're saying the 99th percentile, it means 99% of data. Adeline, good question right there. We'll do that next. Yeah. For the content quiz 4. Yeah, let's actually do Canvas content quiz next. Let's do that. I'll actually just briefly mention this here, and we could come back and do more questions. But Adeline, do you want to do Canvas content quiz 4? We'll do it right here, and we'll do a bunch of the questions, and it'll kind of show what the test is looking like for this. So with this right here, and you can see the different ways that we can give these questions, z-scores and how to find them. You know, like you score this on a test, and the test has a mean of this. So you'd have to give the mean and standard deviation are given. And observation is turned into a z-score. That's how that would work right there. The empirical rule, you have to know the 68, 95, 99.7 rule. And then the applet questions, you'll always look at pictures. So given a picture and solve. That's how it works. It's kind of a breakdown mostly. Once again, watch the review videos, read over the review stuff. This is just my quick idea and understanding from what I've seen over years of teaching on how we kind of test your knowledge. But we have someone here, so we take your questions. So if you're watching this, you're like, man, Brian, I feel like you should have gone into way more detail. You should have covered your mouth with your cough. I said, no one's in the room. I'm sorry. I'm sorry. I say swing by office hours. We'll do some work. We'll do it. We'll do some work. I ate a Quest bar. Apparently it was a little dry. Sorry. Canvas content number 4 right here, due February 21st. So we got a little bit of time. And because we're going to do this next class, I like to move Pivot around a little bit because Pivot's short and easy chapter. So chapter 5 is the tough one. Does that make sense, Adeline? Chapter 5 is a tougher chapter. It's not like really tough. It's just if you don't know it, it makes no sense. So you have to start chapter 5 early and tell people, start this early, as they do a lot. Okay, so we're going to start this early because we've got 3 days. And Adeline, shouts to you. 1,000 points. Meebot hasn't even given out any points yet. This is Canvas content number 4. If you ever don't find something in video, just swing by here. Stat 201. Canvas content number 4. Adeline, help me out right here. Let's see how many of these we can do. I'm going to ask you for your advice. Oh my gosh, it's like we got a z-score thing. So what is the equation for a z-score? It says we need to turn this into a z-score. Well, we were just talking about z-scores a second ago, and we said we need the mean and the standard deviation. So we need the mean of the curve. Do you remember the equation for a z-score? What is the equation? Observation minus mean over standard deviation, because it's how many standard deviations is something away from the mean. So observation of y minus mu mean, we're color coding this, sigma standard deviation. So nice and easy. It's below the mean, and it's going to be a z-score of about negative 0.4, maybe. So observation of, this is equal to 476 is the observation, which is below the mean of 483, negative z-score. Do not forget the negative. Divide by 21.9. And we get the z-score. So this is how many standard deviations it is below the mean. That's all we're finding. And z-score can be positive or negative. 476 minus 483 divided by 21.9. And there it is. And we got it. I think you can enter all the decimals. I think it's fine. We'll find out. Some of them matter, some of them don't. Next one right here is the what. You are using the what rule, which is something we just mentioned. Really good review right here. Test questions will tell you when you're using this, what rule is this? 68, 95, 99.7. known as the, and I'll throw you more points, Adeline. Get all those points here in office hours. This is the what rule? What rule is this? It is the empirical rule. Adeline winning all those points right here. This is the empirical rule. And what you want to do is you want to draw it out. Draw it out. And we're going to go ahead and do that by drawing out our normal curve. Ooh, pretty nice normal today. And we draw the line underneath to show us what's going on. And now we put at the center of the curve 0. And then we go up 1, a 2, a 3, as the owl once said. And we go down 1, a 2, a 3. There are more standard deviations outside of this. It's just that very little of the data is contained outside of this. 99.7% of the data is contained within plus or minus 3 standard deviations. Within plus or minus 2 standard deviations is 68% of the data. That is the largest portion of the data contained around the mean/median, which is found here at a z-score of 0. And we might have to move this slightly down or give myself some more room because we have to put here the mean of 25, which goes at the center of the curve. I knew it was going to do that. 25. Perfect. Now we're fine. And go here to 28. We're doing a longer solve on this just to make sure we can get all the numbers and understanding out of it. And we go down now, and you're just going up and down the amount of standard deviation. So this distance right here, a distance of 3, which is the standard deviation. In the curve of the normal curve, this is normally distributed with a mean of 0 and a standard deviation of 1. And the curve down below, the drawing I'm doing, really, I had it nice and perfect, is normally distributed with a mean of 25 and a standard deviation of 3, which means we have here 19 and then we have 16. So it asks what percent of runners should be below 22 minutes. And I want you to tell me, do you know what percent of runners will be below 22 minutes? See if you know the answer on the screen. This is the visualization of it, which should give you a guesstimate. Think about what percent of the pizza or curve I'm shading. I think if I say what percent of the pizza has been shaded, it makes more sense. You're like, the curve? It's like, it's just a place. Darius, good to see you there. Who knows the answer? I'll start giving some hints. This is an exact answer we need to find. What is the answer? I'm giving hints by doing this. The middle 68% is contained within plus or minus 1 standard deviation. See if you can get the answer before I say it. 16%, Adeline on fire right there because 32% is contained outside, which means 16% in either hand or either side right there. Once again, you want to think if there's 68% inside, 32% outside, and cut that in half. And a good way to check your numbers is if you draw like this, you should get 100% if you go across the curve like that, because you'd be shading everywhere across. So below this mark right here is 16%, and these questions become really easy. Make sure to check if it's above or below. A p-value for correlation, which is statistically significant, implies correlation is due to random chance. So this is just a thing to know. And this is a keynote to have. I'll write down the keynotes for this one. Statistical significance is p-value less than 0.05, which is usually alpha. Alpha is assumed to be 0.05. It's technically less than alpha, and alpha is assumed to be 0.05, but most people pretty much always will say p-value less than 0.05 because that's the assumed spot we find significance at. Pretty much all statisticians and all researchers use that. It can be changed if you change your alpha. More on that in a later lecture. But the p-values are statistically significant when they are what? Low or high. P-values are statistically significant when they are low or high. So statistical significance is less than 0.05. So a what p-value is statistically significant? I'll write that on the notes on here. A what p-value is statistically significant? Low. And so low p-values are statistically significant. Great job. And what this means is the p-value is a probability. That's what the P stands for probability. It's a probability value. It's the probability of what you saw or something more extreme by random chance given the null is true. And I know that's a lot to take in. I'm going to give you a very short example of it. Brian says he can run an average mile. That's my claimed average mile time, mu naught, of 5 minutes. So what would you expect Brian to do? If I say, I can run a 5-minute mile. Yeah, we'll do some chapter 6. You got it, Daryl. If I say I can run a 5-minute mile, what would you expect me to do? I say, I can run a 5-minute mile. You say, okay, well, then I expect what? What would you expect? If I say I can run a 5-minute mile, what would you expect? Don't go crazy here. Just say, I say, I can run a 5-minute mile. You say, I trust Brian. You expect me to run a 5-minute mile. And that'd be at the center of the curve. So if I were to run a time, and we'll just say a hypothetical time that is around here, but a little bit over, does that look probable or not probable? Say probable or not probable. If I run a time, Darius and Daryl, both good to see you. If I run a time right around there where that line is at, does that look probable or not probable? Looks probable. If I run a 501, you're not going to be like, Brian, you ran a 501. I'll be like, that's basically a 5-minute mile, just some random variation in there. So it looks probable. But if I run a time over here, I run like an 8-minute mile, and I say, no, I swear that was, like I run an 8-minute mile. You observe my average mile time is 8 minutes. You say, Brian, that would not occur. Low probability. That has a low probability of occurring. If you are truly a 5-minute mile runner, we would not expect you to run an 8-minute mile by random variation in your mile times. So what does this say? A p-value for correlation, which is statistically significant, implies that it is due to random chance. Low p-values are unlikely by random chance. As in, if you were to see me run that mile time that was so far away, you would say, I don't think it's due to random chance that you just ran that mile time. I think you're actually not a 5-minute mile runner. I'm like, no, sometimes 5-minute mile runners run 8-minute miles when they're trying really hard. And you're like, no, Brian, I don't think so. That's not the way it works. This is false. It's a lot to learn there, but a p-value for correlation, which is statistically significant, would imply it's unlikely or not due to random chance, would imply it's unlikely. Because unlikely means not probable. And the p-value tells us the probability of our results by random chance, given the null is true. I could talk about the correlation example too and apply that where correlation's null is no correlation, but I think it's easier with, let me mention it. I'll mention it. It's easier with the running example. That sticks with more people usually. If we assume no correlation, which of these graphics, A or B, would be likely to see if there's no correlation? If there really is no correlation in the data, which of these graphics would be more likely to see? If there is no correlation, if we assume there's no correlation in the data, which of these would be more likely to see? Don't worry if you get it wrong. It is A, because A looks like what you expect giving no correlation. That would put the p-value for A very what? High or low? The p-value for A, because it's what you expect to see by random chance given there's no correlation, it would put the p-value very what? It's what you expect to see, very high, exactly. This would have a p-value of like something like this. And then this, don't worry, Daryl right there, 1,000 points. The p-value for B would be very low because correlation like, or something occurring like this would be very what occurring? This occurring by random chance would be very unlikely. Does that make sense? If there is no correlation, this result down here, what you observe, is very unlikely. If there is no correlation, this is a likely result. Does that make sense? It's a lot to take in. It's a big stats concept. But if you get it, you got it. So that's the review of what it means to assume no correlation. And that's what would be right here. A p-value for correlation, which is statistically significant, i.e. low p-value, implies that correlation is due to random chance. No, it would imply what we saw is unlikely due to random chance, low p-value. This one's pretty easy. If I tell you that the 4 ways to describe it are shape, center, spread, and unusual features, you see one of the ways to describe univariate data inside of here. So what is it? Exactly, p-values are probabilities showing probability of by occurring by random chance. Is A, B, C, or D is the wrong answer. One of these is the way to describe univariate data. Is it shape? I said the answer. It's shape. Shape, center, spread is univariate. Strength, direction, form, unusual features is bivariate. So the only one missing from here is unusual features. A strong relationship can have a correlation of 0. We'll do a little chapter 6 here coming up. So a strong relationship is measured by the tightness. So which of these relationships is stronger? Which of them is tighter around its form? Is B stronger or is A stronger? Is A stronger or B stronger? I'll tell you the answer to it. Which of these is stronger? I'll do one more version of this, and we're going to do chapter 6 right after this. It is A. Because B might have a stronger correlation, but correlation only measures linear strength. So just because something has a correlation of 0, it means no linear strength. This is a very strong parabola. This is not as strong linearly because the tightness around the form is the strength. Does that make sense? Like how this A is tighter, it's stronger, but it's not, it doesn't have a higher linear strength. So as the question states, can you have a correlation of 0 and have a strong relationship? Yeah. It would just be you do not have strong linear relationships. Very true. It would just be not a strong linear. I always double check. I don't think I'm going to get anything wrong. We'll do one more version right here. We didn't hit any of the applet questions. And then we're going to do chapter 6 right after this. Here's an applet question right away. Now, this question seems really tough, but we're looking at the what right here. Tell me what we're seeing visually. This seems really tough. You're like, no way can I get this. And this is how we test you on it. We'll give you a picture. Tell me what these things are. What are those things? Because it's on this curve. I'm going to highlight things I want you to talk to me about. Give me any help on this. Those are z-scores. Daryl, that's exactly the answer I wanted. Those are z-scores. They're the z-scores for the what? They're the z-scores for the what? This is where this is. This is where... They're the z-scores for the what? Kind of. Go here to this, though. They're the z-scores for the what? Because we're not at 68, which is at 1. We're at something else. So we had to go in. Because we're not at 1, 2, 3. We're using another z-score not given to us by the empirical rule, the middle 60%. Great job, Adeline, right there. Yep, that's the middle 60%. So how much is over here on the curve? Let's do a different color. How much is over here on the curve? How much area is over there? If 60% is inside, what is outside? How much is over there? How much is over there? Remember, it's 60% on the inside, so how much is that worth? Close. 20. Because we have to, if this is 60, then we have to have what by adding up all the numbers. If you add up all the numbers, because if that's the middle 60 and it's symmetric, so the outside parts are also symmetric, then what do you have right there? You have 100% of the curve. We need to find what? The question asks us to find the what? And where, can you find where that's at? Do you know some information about that? Do you know where the 80th percentile would be? Yeah, great job, Darius, right there seeing it. Do you know where the 80th percentile would be? Do you see, is it on the curve anywhere here? What does 80th percentile means? It means 80% of the data is where to that. Boom, Daryl's on fire right there. There it is right here. Because it means 80% of the data is below this point. Does that make sense? So we have the what for the 80th percentile? We have the z-score. And what you could do is you could put the numbers down here, 98.2, 98.9. So what would you know about the temperature of the 80th percentile by looking at this visually? By looking at this visually, the temperature of the 80th percentile, because I just put the mean here in the standard deviation, it always helps to put this, the temperature is going to be about what? I mean, could you guess at it? I mean, I bet you could guess it. I mean, we can solve it too. Because you're just going to go to the mean and go up this many standard deviations. We need to go up that many standard deviations. That's the standard deviations we go up. That's the context of the data. If you had to guess to 1 decimal what the answer is, what would you guess? If you had to guess to 1 decimal what the answer is, what would you guess? It's the temperature of the person, what their actual temperature is for the 80th percentile. 98.7. And you know what, Daryl? I think you're right. I think that works. We'll put it in. Just by doing it visually, and now you could go and solve it actually, and you'd have to go here to the mean. We go to the mean plus, that's not plus, really? The mean plus, I'm gonna erase that, I don't like that mean plus the z-score times the standard deviation equals the observation. So it's gonna be about 98.7, I think it's almost exactly that, and the mean is 98.2, and then from there we do plus the z-score of 0.842, and then we times it by the 0.7 standard deviation. And I think you're right. Because we go right here in 0.842 times 0.7 plus 98.2. And it does round up, but I think it has a plus or minus, so we're going to leave our answer because I think you got it. Here's another one with the below 22. That is a z-score of -1. Below it is going to be 16%. It's not always the same. It's due by random chance. No, it's not due by random chance. Which of the following is a bivariate display? Adeline, we got this. Are bar charts univariate or bivariate? Are bar charts univariate or bivariate? Are bar charts uni or bi? A bar chart, not some stacked stuff down here. Are bar charts uni or bi? It's a good graphic. This is the Canvas content quiz. Rachel, ask any question. We're going to do some chapter 6 coming to Max. They are univariate, so that's not a right answer. Are histograms univariate or bivariate? A histogram. A histogram is univariate. How about mosaic plots? Those are bivariate. Mosaic plots are bivariate. But they're what? Mosaic plots are bivariate, but they are what? Mosaic plots are bivariate, but they are what? Gotta look where I'm at. That's why I keep disappearing right here. They're categorical. So the answer for the bivariate quantitative is scatterplots. Scatterplots are bivariate quantitative. A strong correlation or strong relationship, not correlation, can have a correlation equal to 0. That is true. Sorry for the misclick because I misspoke. That is true. I think we've done a lot of these. Maybe we'll do one. I'm going to see if I see anything else really big right here. We did this one. That's the same. I think it changes some. How does normal probability plot determine if the distribution is normal? It follows the line. Which of these is not part of it? Shape. Strong relationship can have a 0. If correlation of variables is close to 0, this implies there is no relationship. That's false. That's true. And these two are the same idea. I misclicked. But that's the same idea, is that correlation of 0 does not mean no relationship. It only means no linear relationship. Very important right there. Above 31, that's a z-score of 2. Does anyone notice as quickly as I do? 1,000 points. Just take a guess. I could draw this out, but we're going to do chapter 6 right after this. What is the answer above 31? It's a z-score of 2. Because I just went to 25 and went 28, 31. And then I'm saying above 2. If you've practiced the empirical rule, you get this really quickly. You just look at these on the test, you're like, you should draw it out. Does anyone know? Take a guess. Boom, on fire. I mean, are these not... They're easy now. If you know how to do them, you just go to your drawing and you just say, well, I figured it's a z-score of 2, so I go here and I go up, and then I go here in 95. And that leaves 2.5. So, Daryl, are those pretty easy now? Like, after you've practiced and done a lot of chapter 5, should be pretty easy. Below 16, we did that one a lot. Correlation is not affected by outliers. Correlation is totally affected by outliers. That is false. Outliers can do anything to correlation. It's due to random chance. It's not due to random chance. There's no relationship. That's false. There we go. Hey, we got a lot right here. I think we got all 10 out of 10s. Let's do some chapter 6. Hop on into it. Hop on over. How's everyone doing today? We got some chapter 6. Chapter 6. We do the full homework? You want to do the homework? Do the full homework. And then we're done with all the homework for the test. Here we go. Over to the homework. Oh my gosh. Homework. Okay. Canvas content done. A lot of examples. I think there was one applet question we didn't do. Can't remember what it was. It's a good one. Stat Tool 1. Chapter 6. Homework. MyPearson. Let's do it. Okay, chapter 6 is on correlation, which is the relationship between two quantitative variables. Suppose you want to collect data, you make a scatter plot. Which variable would be the best explanatory variable? Now, why do you think I call it the explanatory? When you make a graphic, you have the explanatory. And why do I call it the explanatory? Because it's the what variable. Why do I say maybe a Pokemon's defense as explains... a little obvious right there. Maybe a Pokemon's defense explains the X variable, why it has a certain attack. So when you ask someone why, you want a response. So the Y variable is called the response. It says factor right there, but I call it the explanatory, and the Y is called the response. And you make, whoa, I got some outliers and craziness. That's a pretty good linear relationship, though. So we can look at the correlation between two quantitative variables. So this one is a classic. It doesn't matter. It doesn't matter. It doesn't matter if you do weights and grams or weights and ounces or whatever. With this right here, we'd expect this to be perfectly linear because weight explains weight. Like, It's like if I convert the weight, it's going to have the same. You could just do the mathematics, and it's going to be a perfect linear relationship. It doesn't really matter. It's going to be perfectly created. It's kind of a weird one. Okay. Would you expect to see a perfect positive relationship? So it'd be positive, perfect right here, perfect correlation, because literally weight perfectly explains weight. Next one is ice cream sales and air conditioner sales. Well, I think I know this one. With this, it depends on which salesperson we are. Are we selling ice cream? Or are we selling air conditioners? So the one we want to understand the sales for would be the one we are selling. So I don't know if we're selling ice cream or air conditioners, so whichever one you want. When do you think people eat more ice cream? When they're using more air conditioning or less air conditioning? Like there's more ice cream eaten when there's more air conditioning being used or less air conditioning being used? When do you think people eat more ice cream? We just go theoretical. You might say, Brian, I looked at the data. Data doesn't show this, but just go theoretical with me. I would say more AC is more ice cream, and that indicates a positive relationship. So a positive relationship is when the variables follow each other. It could be also less AC, less ice cream. That's following, as in the variables go in the same direction. But when you say something like the more you drink the night before the test, if you're 21 and drink responsibly, your choices, you do you here. But if the more you drink, the lower your grade. And it doesn't mean your grade will be lower. It means we see a trend in the data that typically people who drink more typically make lower grades. You can say, Brian, I had 2 beers and I aced the test over 21. Brian, I didn't drink and I failed the test. I say, well, there's trends in data. It doesn't tell you what will happen, just what is expected. Cause is a bad word right here. So we have indicated there is a positive relationship, probably linear for the most part. Curved relationships, I don't think any of these are, but they goes to exponential stuff. Shoe size and grade point average. If you're a freshman, you probably want to predict your what? You say, Brian, I want to predict what? You probably look down and say, oh, that's shoe size. I want to understand what? Think of the why here. Why this? What would be the variable of interest? The y variable is sometimes called the variable of interest. Yeah, we'll do some chapter 6 quiz. Yeah, tell me some questions, Daryl. We could switch to that. I could do chapter homework 1 through such and such. Drop some questions. I'll do some of the quiz. You may have done the whole fall homework. So you're here, Daryl. You get to pick. What is the why here? When you ask why, you'd be asking why is my shoe size or why is my grade point average? What is the why that we want to understand? Remember, when you say why, you're saying I want to understand this. Why? Why is my this? Which is the why? Anytime you say why, it's what you want to understand. Why? Good way to remember it. Probably freshmen are wondering, why is my GPA the way it is? So grade point, shoe size would be the X, and grade point would be the Y. It does kind of depend a little bit. We could be a shoe salesman, right? So I do agree. That is definitely, Daryl, let me throw you 1,000 points. Once again, it always depends on context. So I got to give you 1,000 for that. But in most instances, most people would be concerned about predicting GPA over predicting shoe size. But once again, maybe we work at a shoe store. Maybe we're Al Bundy. So you never know. The shoe salesman off of Married with Children. That's old references right here. And what would you see in the scatter plot? Do you think there's a relationship like shoe size predicts GPA? Do you think there's no relationship? What do you think? No relationship, or oh my gosh, Brian, shoe size is positively correlated to GPA. I don't think there's a relationship. It'd probably just be random. Probably just be a random scatter point. There'd be no strength, direction, form, be a bunch of unusual features, a bunch of outliers. This one's really great though. You're driving your car, and are you thinking, how many miles have I driven? Or are you thinking, how much gas is in my tank? Which are you thinking, gas in tank, or are you thinking miles you've driven? Like you're driving your car and you're going to work and you're like, how many miles have I driven? Or you're like, how much gas is in my tank? So which of those is the one you want to understand? Most people are probably thinking what? Is more common thought you have. How much gas is in my tank? You look down. Rarely do you look at the odometer to see how many miles have I driven. You might. But usually we want to understand the y variable of interest, how much gas is in our tank. And the more you drive, the what your gas. The more you drive, the what you get, the what your gas. The more you drive, because this is a quantitative measurement of how many miles you've driven, the more you drive, the what your gas, the less you have. So that's a negative relationship. So it would be the miles you've driven is the explanatory, and then, come on, MyPearson. And then this would be a negative relationship, mainly linearly, unless it could be nonlinear if you go to like maybe like you're doing some like driving on some back roads and you're only going like 5-10 miles per hour, and then you go to like highway and you get better gas mileage. So that's where a nonlinear relationship would come into play. But still, the more you drive, the less you would have. But it might go down like this more sharply where you're driving on the back roads, and then you might have more of a flat downward if you go onto the highway where you get better gas mileage, because then you drive a lot of miles and lose gas slower for miles driven. So that's where they're talking about like a curved relationship. It could be like, what would be the relationship for someone who drives halfway home on back roads and then the other half of the way home on like on a big 12-hour drive, half of it's back roads and half of it's the highway. So then at that point you would do miles driven, and it'd be a nonlinear relationship where it would go like that. It's no need to overly complicate it. It'd be negative linear relationship. They didn't do the back road thing. Okay, which one do you have, Daryl? We can do any questions you want. The National Insurance Crime Bureau. Yeah, and thank you, Daryl. You can drop these at any time. I will try to grab them. And missed it. National Bureau, Crime Bureau, stolen cars. Ooh, so I want you to think about this. Is this a multiple choice one? I might be able to answer it without us even going to it, but let's do it. This was question 1. Car type is a what variable, Daryl? And keep talking to me while we do this. Car type is a what variable? It is. Car type is a what variable? What kind of variable is car type? The type of car you own. What kind of variable is car type? It's categorical. Now, there's a rule for this chapter called QQ, straight enough, no outliers. That's the rules. And what do you think QQ means? To do the techniques in this chapter. To do the techniques in this chapter, what do you think QQ means? QQ, straight enough, no outliers. I used to have people chant that. People yell it at me down the street. Okay. Keep asking questions too. I'll drop more in. What does QQ mean? What in the world is QQ? What does QQ mean? I mean, almost like we saw something back here a little bit. Oh my God, QQ. Bivariate quantitative. It's saying it right there that you would do a scatter plot with it. I just see bivariate quantitative and I know what chapter I'm in. I can say it's a scatter plot. Scatter plot is the visualization of two quantitative variables. Correlation measures strength, direction, form of linear relationships and lets us see unusual features. Where is it? I like those a lot. Those are some of my favorites. If you want to do some of those. Kentucky Derby time. That's a nonlinear. These are fun too. A lot of fun ones. This is a good chapter. Here we go. Wait, this is the wrong one. It's the national. Where is it? This one's a good one too. That's easier than you think. I think you chose the last one, Daryl. You might have. Oh, here we go. Okay. So what do you think? A, B, C, D, Daryl. What do you think right here? It says, is it reasonable to look at correlation? It should say, is it reasonable to find correlation between this? Or can we find correlation? I preferably would say, can we find correlation? It's C. It's not quantitative. I think so, right? Yeah, it's not because there's too few points. As long as you have 2 data points, you can find correlation. Yeah. What other ones should we do? Yep. Have to have 2 quantitative variables to do correlation. So car type can't be correlated because correlation is only a measurement of strength, direction, form of linear relationships, and you don't have linear data if you have car type. There's ways to trick it and discretize data, but you're not. It depends what you're doing. An economics instructor assigns. I'm not an economics instructor. World happiness. If you see a number 2, let me know the number. Then I'll mark it. Thank you, Daryl. We can just do the full quiz. You can just keep asking each one. We'll just do each question right here. You get all the questions done. This one is a lot longer to do. If we were to do all of them, it'd be very hard to do every question and do it justice. So the last learning objective was, as we're getting this question ready, the last learning objective was that correlation can only be measured between 2 quantitative variables. And let's look what this question has us learning right here. An economics professor is looking at GDP. Each student analyzes different factors like life expectancy, literacy rates for a few countries. Apparently, some of the classmates do not understand statistics very well because several of their conclusions are incorrect. My very low correlation of... is mathematically low. Okay, correlation has values that range between what and what? Correlation has values that range between what and what? Does anyone know in the chat? Correlation has values that range. You can look at the graphic. Correlation, yeah, we'll get this one, Daryl. We got it. Correlation ranges between what and what? What does correlation range between? -1 and 1. Now, all these words I put up top are just subjective. Strong is closer to 1 or -1. All this here indicates negative indicates the what of it. Think of a D word. Negative indicates the what it goes. Negative indicates not the strength. The strength is how close it is to -1 or 1. The negative just indicates, think of a D word, which correlation measures strength, direction, form, unusual features. Or it's impacted by unusual features. The negative just indicates the direction or descent. Oh, take that. Indicates the direction. So what the student really has right here is a moderately strong or somewhat strong negative correlation. No, there is a correlation because when there's no association, the correlation will be closer to what value? When there's no correlation, the correlation will be closer to what? When there's no, and that's kind of a hint for it, when there's no correlation, the correlation will be closer to what? And correlation only measures linear strength. The bottom row shows you that. It'll be closer to 0. So although this has a very strong relationship, it has a correlation of 0 because it has no linear strength. Correlation only measures the linear strength. So assuming the relationship is linear, a correlation of this indicates a somewhat strong negative. So you have to look for the negative, and that indicates it. And it's definitely not weak because it's closer to -1. Closer to -1 is stronger. Closer to 1 is stronger. Closer to 0 is weaker. Explain the mistake. The correlation of 0.44. Between continent. Continent is like North America, South America, Asia, Antarctica, Australia. I think those are continents. I don't know. I don't do geography. I know continent is a what variable. That's all I got to know. Don't read their answers. Continent is a what variable, so you know about this. Continent is a what variable. That's the only thing that matters here. You'd be like, California's a continent. I say, that's fine. It's categorical. That's all that matters. You're wrong, but you're right in the theory of how it applies. Continent is a categorical variable. We cannot be doing correlation. Correlation is only the relationship between QQ straight enough. No outliers. Plot doesn't think it's a little bit of regression, but two quantitative variables is needed, and we cannot be doing correlation right here. We'd be doing association of means or medians or some other metric to say there's an association, not a correlation. One of my biggest pet peeves is when people call everything correlated. It's not all correlated. Let's do another one. Most roller coasters. All the questions. Most roller coasters. I was thinking like, is it all aboard? I. My wife knows 80s and 70s music better than me, and I am closer to that time frame. We went and saw we saw Cheap Trick. That was a cool concert to go to. It was like actually like smaller venue. It was at like a county fair or something. It was such a cool, they're like hanging out. It's like, Brian, stop singing. Down the street, the same old thing we did last week. Not a thing to do, but talk to you. It's so good. Okay, let's do the question. Here we are looking at the scatter plot. What do we got? So when you look at a scatter plot, there are 4 things. Tell me one of the 4 things, and I'll start analyzing it. One of the 4 things we should analyze. This one throws me for a loop, so hopefully, I know, such a good song. Immortalized by that 70s show. What are some of the things? What are some of the things we analyze right here? Direction. This is positive. It's pretty strong, too. Pretty strong. Shape. Ooh, shape center spread is for histograms. Adeline right there. We're throwing you some points. But Adeline, shape center spread is for histograms, which is univariate. So shape center spread is for univariate. We're over here in the bivariate world of quantitative relationships. So Adeline, you're right for histograms, shape center spread, and strength, direction, form, unusual features. The strength is pretty strong because it's pretty tight around that line. The form is linear. So this is a somewhat strong. No worries, Adeline. You're getting all those points. You got it. The strength is somewhat strong. The direction is positive. The form is mostly linear, and there might be some light outliers. Like meh. It's overall a pretty good relationship, indicating when there's a bigger drop, the roller coaster reaches higher speeds because it has a positive correlation. So it shows, is it appropriate? Yeah, it's linear. You only use correlation on linear relationships. There are other ways of doing it, but right now we're only focusing on linear. It shows a linear form because it is appropriate. If it was not appropriate, it would show something nonlinear. Show a linear form means the points mostly follow a line. Something that doesn't show that would be something like this right here, because these points, what? Why is this sad time for correlation over here? Why is this sad time? Monster Man. There you go. Why is that sad time over there? So he's related to Monster Man. Why is that a sad time? Because the relationship is what? The relationship in that data is what? It's not linear. It doesn't follow the line. You can always add a line to data. I've had students be like, Brian, I had data that went like this, and I added a line. Your data doesn't follow the line. This is bad. Don't add the line. You only should add a line to describe the data if the data follows the line. Who follows me on this? This over here is bad. This over here is horrific. Because in no way, I can't even spell horrific. That's how bad it is. In no way does that follow a line. This is good. This makes us happy right here. That data follows the line. The data itself is around the line, where over around the other ones it's not. So that's why we're saying it's good right here. It follows a linear pattern. There's really no big outliers. In fact, the correlation is 0.91. So what does that mean? It's strong and it's positive. Well, we got it right there. There you go, 100. Yeah. Closer to 1 is stronger, or closer to -1. Do remember that the sign of the correlation when it comes to strength, it doesn't matter. The sign only indicates the direction. So you can see -1 has the same strength as +1. It just differs in the direction. Drop another one. Is it making more sense, Daryl? You're basically learning the chapter right now by me practicing this with you. Like you're just getting big chapter review right here. So, and then when you get to the chapter, you're like, I know this strength, direction, form, unusual features. Outliers can do anything to correlation. Outliers are just, anything is possible. Anything is possible! I've been meaning to put another thing on the soundboard, Titanic stuff. Because we talk about the Titanic at the start and the end of the class, and I keep meaning to put that on the soundboard. Maybe I should just have I think there's a really bad ukulele version of that or something. My Heart Will Go On by Celine Dion. I haven't played that on piano in years. It's a good song. More questions. We still got 8 minutes. Go write it out. It is scatterplot. Oh yeah. Let's do it. Let me start from the end of it. I've been so tired. Probably because I work out at like 11:30 at night. I go to bed so quickly. I think that's the beauty of working out late at night. You work out at 11:30, and you get ready for bed, and it's like midnight or 12:10. Do some HIIT workout, and then you just get into bed, and you're just like, I'm tired. My muscles are sore. What % of people work out 10 minutes before they go to bed? If I read research that said it was about it, did you see the number I'm trying to do? If I read research that said it's a bad idea, I'd stop. If they're like, actually, is this it? Yeah, this is it, right? Okay, I think I found it. Yeah. If I read research that said it's a bad idea, data driven, I would be like, okay. If they're like, your muscle recovery is actually really bad, then I would say, okay, I'll listen to the data. Okay, all right. Okay. In a scatterplot, we try to describe the direction of an association. A positive direction is one that can be described how. When you think of something that goes in a positive direction, both variables follow each other. So it would, I'm trying to think if I'm mirror imaged right now, it would start down here and it would go like that. So what a positive direction does, it goes like that. And so it would go, you can draw one. So the way they're describing it's kind of weird. I think you're right. This is a positive, so it starts in the bottom left, goes to the top right. That's all these are positive. So that's a positive, that's a positive. And you can see negative over here on the far side. So it starts on the lower left to the upper right. Yep. Good questions. You just know visually what it looks like. We do this next one. Same sort of idea. Wait, is this the same one? Oh, we just did the questions next to each other. Try to do a few more quick ones. We did that one in the quiz, the homework rather. Trying to find. Those are some you have to do data analytics. Explanatory variable. Oof, causes. Okay, this is wrong. It can't be all of the above. We do not talk about causation. Here, I'll drop this one. In which of the following best describes explanatory variables? Oh, and then we'll do this one here. Let's do this next. And that might be one of our last ones. Thank you, Daryl, for being here. Shout outs. Really appreciate it. Okay, I'm going to do this one. And I do want to mention with this one, causation is a bad word. MuBot gets mad at you if you say cause or accept. MuBot will get mad at you. We do not talk about causation in statistics. That's not how we do things here. Because causation implies that things are linked and must happen. We just look at trends or what is expected in the data. MuBot's super mad right there. He's big mad. So I know A is wrong because it mentions causation, and we just won't use that word here. Correlation is not causation. The explanatory variable explains or predicts changes in the response. That sounds pretty good. I got to think about dependent and independent. Oh, the explanatory variable is the independent. I hate that terminology. Yeah, it predicts the response variable. So technically, in mathematical terms, people call the explanatory the independent because the value of y, which is what we want to understand, depends on x. So, yeah. Good stuff. Last one, if we assume the correlation is correct, which of the following is true? Okay, I like it. Okay, we got a lot of time on this. We'll have another office hours over this. 55, 53. Okay. There we go. Save the notes. If we assume... Oh, found it. This is going to end on 2. Okay. A correlation of 0.02 indicates a strong positive association. Daryl, what would be closer to a strong positive correlation? Like, a strong positive correlation probably has values closer to what? What would be strong positive correlation? Probably has values of correlation closer to what? We kind of drew this out earlier. Strong positive correlation probably has values closer of correlation values of what? Ooh, and then positive, it would have to be 1. So you're right. It'd be like 0.9, 0.8, somewhere in there. You know, it gets stronger. It gets perfect if it's 1. All the points are perfectly on a line. So this would indicate really no relationship. If it's 0.02, it's very weak, non-existent relationship. And it'd be, if it's positive, it would be 1. Good answer, Daryl. The next one says, standardizing the variable will make the correlation 0. Would I change the correlation if I measure you in height in inches or feet or miles or centimeters? Would your height and weight correlation, the relationship between it change? Like, oh, well, now things are less correlated or more correlated because we measured the variable differently, like we did it in different units. Do you think the units of a problem are going to change how the correlation exists as a concept between people who weigh more generally are taller? Oh, the answer to part A was it was a weak, non-existent, probably non-existent relationship. That's the answer right there. Do you think if I measure you in height, your height in feet, inches, miles, centimeters, that's going to change the relationship to your weight? That now it's like, well, now it's actually negatively correlated. People who weigh more in miles actually weigh less in pounds. Do you think the units of measurement change the correlation between two concepts? Like all of a sudden it's like, whoa, I thought they had a correlation, but now we measured it a different way. No. Correlation is an idea that exists. Darius, don't worry. Point's right there. No, correlation will not change if you standardize it. And standardizing is just changing it to z-scores. You know what's really interesting? It's in the notes. Some formulas show it, but in some of the formulas, you're actually doing, this has it right here. What is happening to the values of x in this correlation formula? You're taking the value of x minusing the mean and dividing by the standard deviation of x. That's turning the values of x's into a what to find what is called the value of correlation r. So the value of correlation over here, your x's are actually turned into what's is, and your y's are turned into what's is, because you're taking the observed y minus the mean of y over the standard deviation of y. Those are all turned into what's is. Those are all turned into what's is. What are they all turned into? Wait a minute. Don't worry. Think about the first thing. It's an observation. It's this is an observation minus the mean over the standard deviation. Do you hear it? This is turning all your x's into what? This could be called the z-scores of all your x's. Because it's turning into... So if we turn our data into z-scores before we do correlation, would that change it? Because think about this.
It doesn't matter.
And Darius, great work right there. The equation turns it into z-scores. So would it matter if we turned it into z-scores before putting it into the equation? Do you get what I'm saying? The equation's going to put it into z-scores anyways. So if you were to turn it into z-scores and then do it, it would just do it again, but it's already done. So you're already just doing a step. So the answer is, if you change the way you measure your variables, i.e. maybe turn it to z-scores, it would not do it. This statement is false. Standardizing the variable will do nothing. The statement is false. Yeah, will not change anything about it. Standardizing will not change it. Adding an outlier can dramatically change correlation. What can outliers do to your data? When it comes to correlation, adding an outlier can dramatically change correlation. That is the truest of true things in the world. Outliers can change correlation. Outliers can do anything. Anything is possible with outliers.
Anything is possible.
So with that, we're going to head off here. Good work. You got questions, send them my way. I'm looking over there. There's other formulas for R and correlation, all that good jazz. With that, bye for now, everyone. Bye.